Okay, ma'am? My voice should be here, audible, so that you know, evening when you want to, please start. Please think, ma'am. So that evening when you just, when you have free time, you can put it on and read. Because some terminology sometimes, when you listen, you can easily understand and you can easily memorize it. Because you know, these days we do not have time to read also. Even with the poster, time you are so much squeezed, you are so much pressurized with your own studies. My teacher used to say, while I was a PhD scholar in IIT Madras, my teacher used to say, in future, when you become faculty, you will be squeezed. You will not have time. You will not have time to cater to the needs of the students. You will not have time to teach. You will not have time to read. Like much work pressure will be there. You will be squeezed in all directions. He is indeed correct. He is a professor. He is a wonderful person. Then he was the head of the Department of Chemistry. He used to head a research group of more than 20 scholars. He is indeed visionary. Now I understood what squeezing means. We really do not have time for just now. Sign has gone and you have come. I cannot say that I have told to sign and I will not tell you. As a teacher, we should be open to all students and we should treat all students equally. Okay, ma'am. First of all, the poster has come out very well and I am very much thankful to you for introducing me Optimus. Because I really do not know anything about the program called Optimus 2026 in Ramachandra, but for Viveka introduced to me to Optimus and Viveka introduced me to Deepika. So moving, you just have an eye on the presentation, Amma. I will continue to present. So the topic of our protocol is good health and well-being through biodiesel as the clean transportation fuel. By reading the title, I am presenting as if I put myself in your place and I am talking to the examiner. By listening to the title, you may think that this is out of box. This theme is out of the scope because it has no relevance to medicine. But our focus and emphasis is on prevention is better than cure. We want to prevent many of the respiratory diseases, many of the heart diseases, many of the health complications that arise due to poor quality of air. India, the burning problem in India is poor air quality. In Delhi, the visibility is lost and there have been many accidents because of poor air quality, bad air quality. Most of the metropolitan cities, bad air quality is because of unclean fuels. Because when we use fossil fuels like gasoline and diesel, what will happen is there will be excessive amount of greenhouse gas emissions. Greenhouse gas emissions means carbon dioxide is the major greenhouse gas. Okay. Apart from carbon dioxide, SOx and NOx are also emitted, and these NOx and SOx and carbon dioxide are accumulating in the atmosphere and not letting the heat go out of the atmosphere. As a result, no, or a room heat அப்படியே இருந்தாலும் ஒரு குக்கர் மாதிரி இருக்கும். Like that, Earth is being cooked. Earth is being heating up without any control. The global average temperature is rising. Okay. That can be prevented, and the adverse climatic conditions and adverse catastrophic effects of climate change can be prevented when we go for clean fuels. Okay, in this context, biofuel like biodiesel can alleviate the problems of greenhouse gas emission. We do not say that when biodiesel is burned, CO2 is not emitted, because biodiesel is also having carbon in itself. When it is burned, when it is combusted in car, when it is combusted in truck, CO2 will be emitted, but NOx will not be emitted, SOx will not be emitted, because NOx, let me check if it is tightly screwed. In the meantime, you can focus on updating the work report and focus on the review suggestions. Okay, please look at. I will come back after completing the presentation to the students. Okay, please give me some time. 12 o'clock is now. You can go for lunch and come. Please go for lunch and come. Welcome. So the catastrophic effects of climate change can be prevented by using green fuels like biodiesel. We do not say that CO2 will not be emitted when biodiesel is burned, because what we show here is biodiesel is a closed carbon cycle. biodiesel operates on closed carbon cycle. Okay, ma? Closed carbon cycle means the amount of CO2 that is released by burning biodiesel is equal to the amount of CO2 absorbed by plants to eat oil. Ilya? Sunflower oil, agatam, coconut oil, agatam, groundnut oil, agatam. The plants have to grow, no? For plants to grow, they need to take CO2. Plants absorb CO2 and give oxygen. Give oxygen. Emit oxygen, oil. Oil also is coming, but we are not using the oil, canola oil and alone, soya oil and alone, coconut oil and alone, groundnut oil and alone. We are not using as such. There is no conflict between food and fuel. What we are doing is, this oil, sunflower oil or coconut oil or all these oils are used for cooking. Once the oil is used for cooking, there are thousands of liters of oil that is dispatched as a waste. We are taking the zero value waste, using it as a feedstock for producing biodiesel. அது எப்படி நம்ம பண்ணிட்டு இருக்கோம்? We are mixing waste cooking oil. வீட்டில் அம்மா வந்து சிக்கன் ஃப்ரை பண்ணாங்க, வடை பண்ணாங்க, அப்புறமா ஒரு அட்லீஸ்ட் 250 ml ஆயில் அப்படியே வேஸ்ட்டாக போகும் இல்லையா? வீட்டிலேயே ஒரு ஆயில் வேஸ்ட்டாக போட்டோன்னா how much waste cooking oil we are generating in the canteens, in restaurants? Literally large. 1.4 billion people in hotels and restaurants are producing lots of liters of waste cooking oil. We are providing a solution not only to energy needs, we are also providing a solution to the burning environment problem of waste oil management. We are taking this waste cooking oil and then mixing it with methanol, oil, alcohol. You see, this is the scheme. This is the scheme wherein we show the molar reaction between waste cooking oil and methanol. 1 mole of triglyceride reacts with 3 moles of alcohol. It can be methanol, it can be ethanol, any alcohol, isopropanol. 1:3 ratio means if I take 1 liter of oil, how much methanol I should take? 3. Minimum 3 liters. That is the minimum. It can be 4, it can be 5, it can be 12 also, depending on the catalyst, depending on the temperature, depending on the microwave or thermal or something like that. Minimum it should be 1:3. That is the stoichiometry. When you take 1 mole of triglyceride, 3 moles of alcohol, 1 mole of triglyceride reacts with 3 moles of alcohol, and we are getting 3 moles of fatty alkyl methyl ester, FAME. 3 moles of, this is the biodiesel. This is the biodiesel. FAME is the biodiesel molecule. This is the trans-esterified product of waste cooking oil. Waste cooking oil contains triglyceride. Waste cooking oil is triglyceride. Triglyceride reacts with methanol to give esteric form of triglyceride. Okay, this is esterified triglyceride. This is fatty alkyl amyl ester, FAME. FAME is also called biodiesel. Okay, ma. In addition to biodiesel, what are we getting? Glycerol. Glycerol is a waste. Glycerol is a secondary metabolite. Any reaction, any reaction pannalum, waste generate agum. In biodiesel production also, via process purification reaction, secondary metabolite is produced, and that secondary metabolite is glycerol. Of course, glycerol can be separated because layer vandrum. Oil over layer varum, glycerol over layer varum, unreacted methanol over layer varum. Oil is biodiesel. How this trans-esterification reaction is taking place is, this is the proposal we are this is the protocol. The protocol we propose is, there will be a microwave oven like this. Okay, like domestic microwave in shop lo adi edutittu simple domestic oven inga oru otu padum or tube ipdi vettam. This tube should not be metallic because metal cannot withstand microwave radiation. Metal and the microwave are not good friends. Okay, ma. This should be made up of Teflon. Okay, ma. Careful. Yes. There's some recording is going on.
Oh, sorry.
No problem. You can take a mustard. Careful. So, if வீட்டில் வந்து அம்மா மைக்ரோவேவ் யூஸ் பண்ணாங்க, if mother uses the microwave, mother will not put a stainless steel box. You give lunch in stainless steel box. Mother will not put a stainless steel box in the microwave. Mother will put a bowl made up of glass. Glass will not react with microwave. It will not have any sparks. If you put metal and put on microwave, there will be sparks. There will be short circuit, and microwave oven will be lost. Okay, so we are not using metal rod here, ma. This is made up of Teflon. Teflon rod is later. This is the protocol. This is the microwave, domestic microwave reactor. Here one hole we are putting, here one hole we are putting. There is this angle, 45 degrees angle or 60 degrees angle on the or a tube, Teflon tube into cylinder. இங்க ஒரு plug இருக்கும், இங்க ஒரு plug இருக்கும். Catalyst will be packed in this reactor. Okay, here is the feedstock. Feedstock is methanol and waste cooking oil in the ratio of 1:3 minimum. And there is a peristaltic pump. Peristaltic pump, kudichirunga? Waste cooking oil and methanol are supplied. Peristaltic pump function enna, it will suck and it will control the flow. It will suck and disperse. It will control the flow rate. Okay, ma? It will take the oil and methanol mixture, and here you know ma, in the keel vandu or stirrer kuda irukum. Stirring bar vechi stirrer aagite irukku. Edukana methanol is not soluble in oil. They need to be mixed. Okay, methanol oil will be mixed, and this peristaltic pump will suck the feedstock, and the feedstock is passed through the cylinder. Here the microwave will be on. The catalyst is millimetric silica, strontium oxide. Strontium oxide as such we are not taking. Strontium oxide 10 grams vandu, strontium oxide 10 grams vandu 10,000. It's very expensive. Prohibitively costly. So we are taking millimetric silica beads. Eppadi irukum beads na kaatren. I'll show you millimetric silica beads. Okay, you see, ma? These are the beads, I'm telling. Okay, ma, these are 6 millimeters, 5 millimeters. No, because I am continuously coughing, no, some cough. On the beads, these are the beads, ma. We do have spherical beads, okay ma? On this millimetric silica beads, each bead 6 millimeters. 6 millimeters is diameter. You have strontium oxide nanoparticles. This is catalyst. Okay, strontium oxide அப்படியே நம்ம எடுத்துக்கோனா இது பேக் பண்றதுக்கு வந்து நிறைய வேண்டும். Beads மேல கொஞ்சம் nanoparticles வெச்சா strontium oxide utilization will be minimized. Moreover, when we are packing the reactor with beads, okay, there will be pressure drop irukadu. Nadula space irukulla, adanaala vandu free oil methanol flow agum. Appadi solid strontium oxide appadi vechona space irukadu nadula, adanaala block agum, pressure build up varum.
There is strontium too.
There is strontium oxide. There is strontium oxide at the surface.
Silica illama vecha pressure build agum.
Silica illamale verum strontium oxide powder vecha, that is a powder no. It is closely packed. Adu vandu it will be a hindrance for the flow of methanol and oil. Pressure drop kuda. This is engineering reactor design. Okay ma. Silica beads vekkumbodhu strontium oxide utilization will be minimized. Inge or kg use பண்ணுவோம், அங்க ஒரு 100 grams போதும். At least 9 times decrease in the amount of utilization. So this is the catalyst.
But this is going to be very expensive, sir.
When we prepare this catalyst, it's not expensive because we can reuse it. We can reuse it. We can reuse it. Catalyst, there is a trade-off, Amma. There is a trade-off. There are cheap catalysts like calcium oxide, eggshell and calcium oxide salam. And cheap. And it will not produce biodiesel at this fast rate. Synergistic effect irukadu. Also rate of production of biodiesel will not very fast. Inga vandu 5 seconds. We are talking of seconds. Okay, calcium oxide, magnesium oxide and sodium hydroxide and the catalyst use pannala inga faster varadu. So we have zeroed in the catalyst. We have zeroed in the feedstock. We have zeroed in the kind of heating, microwave heating, strontium oxide deposited on the silica beads, and waste.
So only oil. Expense will be catalyst.
Only, absolutely, only recurring expense will be catalyst. Zero waste. Waste cooking oil is zero waste. And once we have the reactor design ready, the protocol is like this. The protocol is, we will take the domestic microwave and then put a hole here, put the reactor with the catalyst. The catalyst is packed, and then from the feedstock using peristaltic pump, the feedstock is sucked and sent with force to the top, and at the outlet we are bringing the product and collecting in the same container. Because ஒரு cycle பண்ணும்போதமா the exposure to microwave is not sufficient. quicker circle ஆகும். அதனால ஒரு டைம் நீங்க பாஸ் பண்ணும்போது all oil will not be converted to diesel. 50 is converted, 60 is converted, 70 is converted, some unreacted is there. No. அதனால ஃபர்ஸ்ட் சைக்கிள் முடிஞ்சது. அப்போ கொஞ்சம் ப்ராடக்ட் எடுத்துட்டு NMR பண்ணுவோம். NMRல biodiesel ஃபார்ம் ஆயிடுச்சா இல்லையா பார்ப்போம். இல்லையா? Nuclear magnetic resonance spectroscopy. From nuclear magnetic resonance, there will be fingerprints for oil, fingerprints for biodiesel. Biodiesel form ஆயிடுச்சா, oil எல்லாமே போயிடுச்சா, that is 100%. We are looking for 100% conversion of oil. Second side, we take some product and see. 2-3 times நம்ம பண்ணும்போது நம்மளுக்கு தெரிஞ்சு போகும். Third cycle 100% வருதா. Next time வரும். 3 cycles பண்ணிட்டு we take this drum with 100 liters. Take the biodiesel. Pack the drum with methanol and oil, and then again circulate methanol oil for 3 cycles.
But like, do we have to tell sir evlo catalyst use agudu in order to produce evlo oil?
Absolutely we have to tell. For example, we pack half kg, and then we will produce 30 liters per hour, maybe from 1 kg 1000 liters. 1 kg 1000 liters. Okay, ma'am. That process optimization we will do. That is what results we have. We are going to discuss. Okay, ma'am. Already see. We took this batch microwave oven and then transesterification reaction using strontium oxide 40% on silica beads. Okay, ma'am. And we have shown that the catalyst can be used for 10 times. First time, filter. Take the solid catalyst. Biodiesel separate. Again, take oil and methanol and again add strontium oxide. 10 times you have done the batch reaction, and even after 10 times you have higher than 80% conversion. Okay. So the catalyst can be used for at least 10 times in a batch process. But the problem in the batch process is it's a very small reactor. We cannot have 100 liters. We cannot have 30 liters. So we have to obviously go for continuous flow process when we want a commercial scale. That is the lacuna, that is the problem with the existing microwave technology. We can get 10 times we are doing. But there is a limit for the amount you can get. Okay, commercialization, to the level of commercialization we could not yet reach, because you see, this is the commercial flow-cell microwave reactor from this is the commercial flow-cell microwave reactor from France. Okay, ma'am. This is the reactor. We send, this is the peristaltic pump. Okay, this is the oil and methanol mixture. Okay, from here we are passing oil and methanol. From here, this is inlet. The microwave is on. The product is collected from here and it is again collected here. Second step. Okay, our setup is similar to that. Okay, ma'am. But because we are making it in our home, because we are developing with our homemade technology, simple domestic microwave, domestic batch process continuous of 100 people. Adhanala, we need not spend so much money that the France people are investing. Okay, ma'am. Moreover,
So this cannot be done in home.
This cannot be done in home means we cannot afford to buy that, and moreover, idu panna ivlo the limit. You see, this is the result. If we do the reaction in the flow synthesis, already I have done this in the batch process and proved that we can reuse the catalyst for 10 times. Okay, and when we do the same reaction in a continuous flow process, what is this? 4.5 liters. Time. What is that time? 1 hour. 49 minutes. 49 minutes means 1 hour. In 60 minutes, we can get 5 liters. 60 minutes means in 1 hour we are getting 5 liters of biodiesel in a continuous flow process like this.